From now on, let's think about the several examples for perturbation theory. First one is the harmonic oscillator. We already know that harmonic oscillator Hamiltonian, it is unperturbed. Harmonic oscillator Hamiltonian can be exactly solvable, so it is p square over 2m plus 1/2 m omega square. It is x square. Then it can be write down as the number operator h bar omega a 대거 a plus 1/2. It is harmonic oscillator case. Here, let's think about that perturbation Hamiltonian. Perturbation Hamiltonian like that, 1/2 epsilon m omega square x square. Here, additional epsilon, very small, and less than 1, and epsilon is a parameter, small parameter as a perturbed case. Here, this harmonic oscillator is not degenerated, so, and let's think about that first order correction. Then the first order energy correction is that n0 h prime n0. So here in this case, and the x can be written down as ladder operator, and h bar over 2m omega and a 대거 plus a. Then in this case, and also n0 and the harmonic oscillator 1/2 epsilon and omega square, and the x square is that h bar over 2m omega and a 대거 a square. So a 대거 a plus a plus a 대거 a plus a 대거 n0. It is first order energy correction. So when you think that it is 1/4 epsilon h bar omega, then n0 state, when we think about that a 대거 a, here, I'm sorry, it is a 대거 a 대거 means that it is increasing. For example, n equal to 2, then it becomes a 3 state, and also it decreases if we apply the a 대거 like this, and decrease the ladder decrease the energy level, and for example 2, and becomes 1. So it is not diagonal, it is not from the orthonormal state, it is 0. So like the same issue, and this AA and the lowering state and the increasing state, and it is not coincide with each other, and also here, so only this term should survive in here in this case, and decreasing the state and decreasing the state, and increasing the state and increasing the state, and the same state expectation should be 1. So it is only survive this term. This term n0, and so, and from the ladder operator, an means that square root to n minus 1, and a 대거 n becomes square root n plus 1 and n plus 1. And from this relation, and also here 1/4 epsilon h bar omega, and here in this case here decreasing square root n, and here square root n, so it makes that n. So here it is a square root n plus 1 and the square root n plus 1, so here it is makes that n plus 1, so here it is 1/2 epsilon h bar omega and n plus 1/2. Here E and energy is that unperturbed energy plus first order perturbed energy. So h bar omega and n plus 1/2 is that unperturbed energy, and the perturbed energy is that 1/2 epsilon h bar omega and n plus 1/2. So it can be written down like this: h bar omega 1 n plus 1/2 is that 1 plus epsilon over 2. So it is perturbed energy can be calculated. How about the second order correction? Second order correction energy is that summation with m with a difference with n, then n0 h prime m0 should be 0 on a square, en0 minus em0 here like this. So we should calculate at first n0 h prime and m0. Then as we know, this Hamiltonian we already calculated here, here, and here. And anyway, here it is Hamiltonian. So when you write down like this, 1/4 epsilon h bar omega and n0 a 대거 plus aa plus a 대거 a plus aa 대거 m0 state. Then from here 1/4 epsilon h bar omega, and basically we applied a 대거 here, a 대거 here, a here, a apply this, then here square root n plus 1 then square root n plus 2, and second, and here n plus 1, square root n plus 1, and the other operation square root n plus 1. But here it makes that n, and this is the n plus 2. Then they should be equal with each other. N should be n plus 2. Then in this case, second case, plus apply to the a here square root m, and the second application here is that square root m minus 1, and the n should be m minus 2. Like that, here is plus the square root m and the square root m delta nm, and plus square root m plus 1 square root m plus 1 delta nm. Because it is a non-degenerated case, so n should not be m, so it should be equal to 0, and also it should be also 0 because n should not be m. Therefore, the second energy correction is that the square of this one is that 1/4 epsilon h bar omega square, and Okay. N should be the second. The first one. The first one is that En0 minus En plus 2. M should be N plus 2. Zero and N plus 1 and N plus 2. And plus En0 minus En minus 2 0 case here N minus 1 because each term should be a square. Then from this the numerator makes that minus 2h bar omega because 2 energy state 2h bar omega. Here it can be calculated in the 4 times 4 16 times 2 32 epsilon square h bar omega and minus n square plus 3n plus 2 plus n square minus n. Then it is cancelled with each other, and so it is minus 4n minus 2, so it is minus 1/4 epsilon square h bar omega n plus 1/2. So this energy eigenstate is zeroth order and first order plus second order, and h bar omega n plus 1/2, and first order case is 1 plus epsilon half, and the second order minus 1/8 epsilon square. So it is a second order energy equation.